So all students, welcome to the class. We are actually here going to discuss about the term that is called gaseous state. Gaseous state, or in some books it is mentioned as states of matter, right? In some books they have mentioned as states of matter. Now in NCERT or in the state board book they have mentioned states of matter, while in other competitive books they have mentioned as gaseous state. No need to worry about it. But the thing is, here first we must have a general knowledge about the term that is called matter. In the junior class also you have studied about the matter. So what is matter? The question is coming that. So we can actually define the matter as matter is anything which occupies space and has mass. Right? Anything which occupies space and has mass, that is called matter. So there are many examples. For example, we can say, we can have your pen, then smartphone, it is also a matter only, right? Even human body is also a matter, right? Many other examples are there matter, because pen itself has some mass in grams and it occupies certain space. That's why it is also a part of matter. So there we can classify the matter in different states, right? Matter can be classified into different states. So normally in that case, first one we can classify that is solid. In junior class you have already studied about solid. Second, that is liquid. Third, we can say it is a gas. Fourth, you can take plasma. And fifth one is Bose-Einstein condensate. Bose-Einstein condensate. Okay. Bose-Einstein condensate. So these are actually the 5 categories, means 5 states of matter. Normally, our focus is on first 3 only, right? These 3 are important. These 3 are very important. While remaining other, actually it has of less importance. So in that way we can say here, our main concern is the solid, liquid and gas. Normally we have studied since the junior classes also. So our main focus will be on these things. So here we have. Now there are actually 2 forces are acting on a given matter, right? There are normally 2 forces are acting on that case. So we can say there are always 2 opposite tendencies. 2 opposite tendencies between matter which determines the states of matter. Means 2 things are responsible, 2 opposite tendency, they are responsible for the states of matter. That defines about the nature, their size, their motion, their attractive force, they will be defining them about information regarding the matter. So states of matter in that case. So first one we are going to deal in that case. The first one here we have in that case is the intermolecular attractive forces. This is the first one. And second one in that case we can simply say that intermolecular motions and space between them. So whatever the force of attraction is there between the 2 molecules, that is bringing them closer to each other. As well as there are actually intermolecule between 2 molecules, there will be certain motions also and certain space is there, so that they won't be coming extremely close to each other. Means both things are balancing them one by one. So this is about the 2 tendencies, 2 opposite tendencies are there in that case, which are balancing them each other, right? Which are balancing them each other in this manner. So next we are going to go for the classification, right? We are going to classify the matter first one. In that case, in classification we are going to discuss about, so largely our main focus on the 3 matter, right? 3 physical matter in that case. That is, we can say the matter can be classified into the three categories. Okay, matter we can classify into three categories. Their properties will be there, as well as their different state will be discussed in that way. So on one side you take the properties, right? One side you take the properties in that way. Another side you can take here, there is a properties we can say. We are going to discuss the properties in that way. So there are properties in that case. Next, there is actually certain natures in that way. So we are dealing with the three types of matter and their property we are going to discuss about. So first one in that case, our solid. Our first one we take solid in this way. Solid is there. And you know, in the junior class you have already studied about the solid also easily. That we say that solid means those which have definite shape and definite volume. You have already studied about it. Right? Then there are certain liquids also. So solid, liquid and gas, these three things you have already studied many times in your junior classes. Right? Solid, liquid as well as the gas. Solid, then comes liquid, and finally we have the gas. So three columns in that way, and one by one their property we are going to study. So it will be useful easily and it will be understandable. So solid, liquid and gas, these three are the main concern for us while discussing about the properties. So in the property, the first one we are going to discuss is about the attractive force. Right? We are going to discuss about the attractive force. Right? Attractive forces. So when we discuss about the attractive force, here simply we can say in this manner. So attractive force, the nature of forces in the solid will be, in that case, the forces are very, very large. Right? There is actually strong attractive force between the two molecules. Here we can say. Between the liquids, relatively it will be less. Okay, it will be less. While in case of the gases, we can say it will be the least one. Right? Almost zero. So because the force of attraction is more in the case of solid, that's why they are very, very tightly packed. Then comes another one. The second factor is the volume. Right? Second factor in that case is the volume. So because they have a stronger force of attraction, so we can say they have actually, in that way, they have a definite volume. So these have a definite volume in the given case. Similarly, liquid also have a definite volume. Right? Liquid also have a definite volume. But when we talk about the gases do not have a definite volume. Okay? No definite volume we can say. Right? No definite volume it has in this case. Next, about the thermal motion. Thermal motion is depending on temperature. Right? Thermal motion, it is depending on temperature in that case. So simply the thermal motion in the case of solid, it will be very, very less. Right? Molecules only vibrate at its own point. So we can say thermal motion is almost zero in this case. In the solid, the thermal motion is almost zero. But in case of liquid, it will be, in that case, it will be relatively greater. If the temperature change happen, molecule will start moving also very fast. So it will be greater. But in case of the gases, because the force of attraction is very least, in that case motion will be random. So we can say random motion will happen here. Random motion will take place in this case. Then last category left in that case. So we have discussed about the attractive force, volume, thermal motion we have discussed, as well as we are going to discuss about the shape. Next thing is shape. So when we are actually concerned for the shape, we got an idea that already because the force of attraction in solid is very large, so we can say it has a definite shape. Solids always have a definite shape. While in case of liquid, the force of attraction is relatively less, so we can say it is not fixed. It is not fixed in this case. Then switching for the another concept, while in case of the gases, it is definitely, we can say it is not fixed here, right? So because they do not have a definite shape in that case, so in whichever instrument they are actually poured, whether liquid or gas, wherever instrument in which they are poured, they are occupying the shape of that given container. So in this way we can classify the matter, and their property we have also classified accordingly. So what we have learned, matter is anything which occupies space as well as having mass. This thing we have learned. Then our main concern is solid, liquid, gas. So two types of tendency are acting on it, that is intramolecular forces as well as the intermolecular motion as well as the space between them, and these property we have discussed. This is the idea we are actually going through. Now certain important variables are there while discussing about the properties of gas. While discussing about the properties of gas, we know that matter consists of solid, liquid as well as gas. So their property we have discussed here. Next, now we are concerned with the properties, or we can say variables. So variables to define the properties of matter, right? Properties on the, we are focusing because the chapter is gaseous state. Our main concern in matter is actually the gas. So we are going to discuss the variable to define the property of a given gas that we are going to focus on. So let us begin in this case. So first property, the important one, that is the first one we have to discuss, that is the pressure. So pressure is very important, right? Pressure is the first property we are going to focus on. So in this case, when we say, here suppose there is a container, this is a container, right? In this container we have actually filled the gases, right? In this container we have filled different gases in that case. So here this is a gas molecule, this is another gas molecule. Likewise many gas molecules are there in the given container. So the gas molecule, because the force of attraction is very less, what will happen? This gas molecule will move on this side, this one will go this side, this one will go on these different directions we can show. So because the force of attraction are actually very less, then there will be random motion. The molecules inside the gaseous container, inside the container, they keep on moving from one side to another, and because the molecules are moving from one side to another, there will be momentum. There will be certain momentum in that case. So hence we can say, in the gas container, the molecules have some momentum. They will move and colloid with the walls of container. So definitely they will colloid with the walls of container. And what happens when they collide with the walls of container? They will exert pressure, okay, and exert pressure. So pressure will be exerted on the walls of container due to the collision, okay. Due to the collision, the pressure will be exerted on the walls of container here. So we can say simply here, the concept we can explain the definition. So gases exert pressure due to collision of its molecule with the walls of container, So collision will happen, means molecule will definitely hit, and this is a container, suppose it is a rectangular container, area will be there in that case. So simply we can say pressure denoted by, in that case symbol for this one is taken as P. So pressure is equal to force divided by the area. Force acting per unit area, that we say as a pressure, right? That we say as a pressure. So force divide by capital A. This is the idea. So with different color we can say, so we know that P equal to F by A, and SI unit already we know. Force SI unit is Newton. So SI unit of force, normally we take Newton, and SI unit of area, that is A, it is taken as meter square. Meter square we have taken the area. So now we can mention the unit of pressure. Unit of pressure normally we get by dividing simply. So the unit of pressure, in that case it will become in this manner, that the given part we can say P is equal to, unit we can say Newton per meter square, right? Newton per meter square. So SI unit, or we can write SI unit of pressure, in that case will be Newton per meter square, or normally we have mentioned the term we have given, the scientists have given is Pascal, right? Short form for this is PA. So this is the SI unit of Pascal, right? SI unit of pressure is Pascal here we have taken. So sometimes they have mentioned Newton per meter square. When we discuss about the CGS unit, that is centimeter gram second unit, CGS unit is different. So up to here we got an idea that SI unit of pressure is Newton per meter square, or we can say Pascal. So CGS unit, if someone asks you CGS unit of pressure, in that case it will be simply we can say dyne per centimeter square. This is actually unit of pressure here. So we are getting what is actually simple pressure. So on the walls of container, the molecules are colliding, they are actually exerting some pressure in that way. So molecule itself have some momentum, so they will have some force. In that case they are hitting the walls of container having a fixed area. So force divided by area, that will give the pressure information. So normally we can say in that case, so other units of pressure which are more commonly used, other units of pressure, used in calculation. In that case they are using the first one, that is the atmospheric pressure we are using. Atmospheric pressure, short form for this is ATM, right? Second we take bar, that is barometric pressure, right? Bar is used sometimes. Sometimes we use the term torr. Sometimes we take mm, Hg, millimeters of Hg, millimeter of mercury, bracket, mmHg is also used in that way, or sometimes it is mentioned centimeter of mercury. Okay, centimeter of mercury, short form cmHg. This is also used. So these are the other units for pressure which is used in calculation. Now certain important relationship we have to focus on, right? So relationship between bar as well as Pascal. Now one thing is clear, one important statement in that case, always remember, 1 bar is equal to 10 raised power 5 Pascal, right? This is very important. 1 bar is equal to 10 raised power 5 Pascal. It is a very big unit, right? Means 1 bar contains 1 lakh Pascal. Very high unit, very high difference. Now some relationship between the atmosphere as well as the bar we can say, right? If so, normally the drunken person first will go to the ATM, then only he can go to the bar only. Okay, just joking, no need to take it seriously. So relationship, we can say one ATM is equal to 1.013 into 10 raised power 5 Pascal, right? 10 raised power 5 Pascal is how much? That is 1 bar, we can say, right? So we can write it as, or for this one we can write simply 1 point, or if we multiply by 100, 101.3 into 10 raised power 3 Pascal, we can write in that way, right? 101.3 10 raised power 3 Pascal, or 10 raised power 3 means kilo, so 101.3 kilopascal we can write it as. So all three are same. Whether you write 1 ATM is equal to 1.013 into 10 raised power 5 Pascal, it is also correct, or you can write 101.3 kilopascal, that is also correct, right? This stands for the kilopascal. So this is also correct here in this case. So hence 1 ATM is also equal to 1.013 we can say bar, because 1 bar is equal to 10 raised power 5 Pascal. This is also right. So 1 ATM is equal to 1.013 bar, or this is also equal to 760 torr, this is also correct, or we can say 760 mmHg. 760 mmHg, also this is also equal to 76 centimeter mercury. So these three are completely same, right? These three are most commonly used in the unit conversion. Be careful, be very careful in that case. And relationship between them, these are more frequently used up, right? So these are more important. So 1 atmosphere conversion we have discussed here. They are more prominently concerned for us. So copy it to here, this is very useful. And one extra thing, 1 bar is equal to 750 mmHg, or we can say 750 torr, or we can say 75 centimeter mercury. So these are the certain relationship. Be careful and copy them very carefully, because conceptual question is asked from these things, right? Conceptual question is most commonly asked from these things. So next variable we are going to discuss regarding the property of gases. In that way, the second one comes is the volume. Second concern is our volume here. So let us begin with the volume. Second variable, that is the volume. So we are focused on the volume. So SI unit of volume is commonly is meter cube, right? Meter cube is actually the SI unit of the volume, we can say here, right? So meter cube it is 1 meter cube. 1 meter cube is equal to 1000 decimeter cube, right? 1000 decimeter cube. So dm stands for the decimeter cube, right? dm stands for the decimeter cube, and this 1000 decimeter cube is equal to 1000 liter, is equal to 1000 liter here. So dm stands for the decimeter. 1 decimeter is equal to 10 raised power minus 1 meter, right? 1 decimeter is equal to 10 raised power minus 1 meter. So certain relationships are useful in that way. 1 decimeter cube, 1 decimeter cube is equal to 1 liter. 1 decimeter cube is equal to 1 liter. This is also equal to 1000 ml, and it is also equal to 1000 centimeter cube. 1000 centimeter cube. In the US notation, they are commonly used the cubic centimeter, 1000 cc. So this term cc means cubic centimeter. Cubic centimeter. In the USA, the volume is commonly used the cubic centimeter. So no need to worry about it. So one relationship we are getting here. So 1 decimeter cube is equal to 1 liter is equal to 1000 milliliter is equal to 1000 centimeter cube, as well as we are getting 1000 centimeter cubic centimeter. So no need to worry about. Now one important relationship we are getting here in this case. So always we are having a one idea that 1 centimeter cube, from the numerical point of view, 1 centimeter cube is equal to 10 raised to power minus 3 decimeter cube. And remember, 1 centimeter cube is equal to 1 ml, and 1 ml is equal to 1 cubic centimeter, right? All three are here the same. Just to confuse you, sometimes we mention as centimeter cube also. So this is the concept regarding the volume, the variables regarding the volume here. So these three things are there. So hence we are learning that SI unit of volume is meter cube, right? So 1 meter cube is equal to 1000 decimeter cube. That information we are getting. Then we are actually getting the knowledge that 1 meter cube has 1000 liter, and 1 decimeter cube is equal to 10 raised to power minus 1 meter. So the interconversion, their calculation are more commonly asked. So be careful in such cases. Next we are going for another one. Third variable we are going to discuss. So the third variable here is the temperature. So third variable which is important while defining the property of gas is actually the temperature. So we know here the temperature decides the coldness or the hotness of a given gas. So temperature, when we are talking about the temperature, so we normally know temperature has three different scales, right? We have the commonly we are using in this case, first one we are using the Kelvin scale. Okay, Kelvin scale given by capital K. Then we have already used up the another scale that is commonly used in our daily life for measuring the temperature, that is the, we can say, Celsius scale. Okay, that is Celsius scale. Celsius. So this scale is also commonly used. Symbol for this one we write as degree symbol, degree C, that is degree Celsius. And third most commonly used scale is actually Fahrenheit. In India we use the Fahrenheit less, but in foreign the Fahrenheit scale is more prominently used. Okay, Fahrenheit. So this is a Fahrenheit scale having symbol. For that one we say degree F. Fahrenheit we are more prominently using for that case, right? So interconversion, they are very important. So if someone asks you what is the SI unit of temperature, so always remember SI unit of temperature is Kelvin given by capital K. SI unit of temperature is Kelvin, and the relation between the Celsius as well as the Kelvin, we can say simply the relation between Celsius and temperature. So relation between Celsius and Kelvin, we can write it down as temperature in Kelvin. Temperature in Kelvin is equal to temperature in degree Celsius plus 273.15. So most accurate one is 273.15, right? Most accurate is 273.15. For integer type question we have to use the 273.15, but if it is an objective type question then use only 273, so that your calculation will be faster. Then we have a relation between Celsius and Fahrenheit. scale. So the relationship is there between Celsius as well as the Fahrenheit scale. That is more frequently used up. So the relation for this one, you can write degree Celsius divided by 5 will be equal to degree Fahrenheit minus 32 divided by 9. Right? Divide by 9. So this is the main relationship regarding it. Between Celsius and Fahrenheit, this relationship is more important. And between the Celsius as well as the Kelvin, we have this relationship. Right? So copy this carefully. Now certain question we are going to discuss about it. So we got an idea that in temperature scale, we actually measure the temperature in 3 different scales. Rankine scale is actually of less importance. Rankine scale, that's why I haven't discussed here, because the importance is less. Most of the time in the gaseous state we are using the Kelvin scale, Celsius and Fahrenheit scale only. That is the idea in this case. Right? So copy up to here first. One question regarding it we are going to discuss. So one numerical part we are going to discuss regarding it. So let us get ready for a question. Question is, calculate the temperature in Celsius if the Fahrenheit temperature is minus 40 degree Fahrenheit. Okay, minus 40 degree Fahrenheit. This temperature we have. So we have to calculate the temperature in Celsius. So remember the relationship in that case. So whatever quantities are given, first focus on this thing. So always read the question carefully. So solution for this one, whatever things are given, first you write it down. So here given. So what is given? Degree Fahrenheit temperature, that is minus 40 we have, and they are asking degree Celsius. To calculate is degree Celsius. So relationship we know for that, that is degree Celsius by 5 is equal to degree Fahrenheit minus 32 divided by the 9. So this is a relationship we are going to solve for that one. So this equation we are putting, and this is our formula. Degree Celsius divided by 5 is equal to difference, that is Fahrenheit temperature minus 32 divided by 9. So let us put the values. So degree Celsius divided by 5. Here we have taken, it is minus 40 minus 32 divided by 9. So let us do for that. So hence in that case, degree Celsius minus they actually add up, minus 72 divided by 9, multiply by 5 here, right? So we are actually 9 8 are 72, right? For sec it will be 8. So degree Celsius will be minus 8 multiplied by 5. So degree Celsius will be how much? It will be minus 40. So answer for this one is minus 40. So this is a temperature in which the Kelvin scale as well as the Fahrenheit scale have the same temperature, that is minus 40. Okay. So our answer is this only. But if somehow they will ask the Kelvin temperature, if someone want to know about the Celsius temperature, okay, the Kelvin temperature if someone want to use, so temperature in Kelvin, the formula is temperature in Kelvin is equal to temperature in degree Celsius plus 273, simply we can take, right? We got the temperature in Kelvin, that is how much? We got minus 40 plus 273, if we add up, it comes out to be, so subtract, it will becomes 233 Kelvin. So this is the temperature in Kelvin of minus 40 degree, right? So this is the all idea, all the variable we have discussed. So this is the basis of the concept of the gaseous state. The next lecture we will discuss the different types of graph that will be useful, and it will give a complete idea how to deal with different types of graph on different laws.